Okay, so I just want to revisit an old topic very briefly. Given with all this topic of slopes and things like that, just to make sure that we're all on the same page. So, even though this doesn't exactly relate directly to demand, it's certainly related given the pricing here. So. We've talked about marginal rate of substitution before, and I just want to make sure that everybody really gets what this marginal rate of substitution is and gets why it is a particular value at the kind of utility maximizing bundle. So what I've done here is I've drawn a utility curve for two goods, both that have diminishing marginal utility, and that's why they kind of sloped this way. And I've drawn this budget constraint line here. So this is your budget set down here. These are all of the things all of the bundles that you can afford are underneath this budget constraint line. And so the price of good A is $10 per unit. So this is good A. The price of good B is $5 per unit, good B. And so you can see that good A, if I spend all my budget on good A, I don't get as many units as good B because good B is cheaper per unit. And I ask, what is my rate maximizing bundle? And geometrically, we're told that the rate maximizing bundle is the bundle that is right here at the point of tangency of these two. And one way that you could see it is if I were to draw another indifference curve that crossed this line as opposed to just grazed it like a point of tangency. If it crossed the line here, then I would know I kind of know that my maximal utility has got to sit on my budget constraint line, because if I can afford more utility and I want to maximize my utility, I'm going to spend it. So I'm going to push everything up to my budget. So I'm going to spend my entire budget to maximize my utility. So if I did have an indifference curve that crossed as opposed to grazed, I might say that, okay, maybe this is my maximal utility. Well, if that's the case, if the indifference curve crosses here, then I hope you can see there's an indifference curve between this indifference curve that crosses the line and this indifference curve over here. So if I was to draw that, so if I put a little pin here, if this was an alternative indifference curve, like that, you might say, well, what's wrong with this bundle? Well, I'll tell you what's wrong with this bundle. That there is an indifference curve in between these two indifference curves, because I know indifference curves by their definition can't intersect. And I also know they fill this space. So this is like a utility of all of these bundles. I'm indifferent for any of these bundles, but these bundles are all better than these bundles, and these bundles are all better than these bundles. So every indifference curve that crosses the budget constraint line has another indifference curve above it that is still feasible. It still gives me bundles in my budget set, but those bundles are going to be better in terms of the indifference curve. So I always want to walk this direction in the indifference curves. So this process stops at this point of tangency here, where this here is the bundle, where the only way to climb up on my indifference curve is to climb in this direction. Like there are indifference curves out here that would be better, but my budget constraint line prevents me from crawling in this direction. So this is the best that I can do. Whereas these, I can actually walk along the budget constraint line, and as I walk along the budget constraint line, I cross better and better indifference curves. But that stops at this point of tangency, where if I were to keep walking along the curve, this bad indifference curve, I end up crossing again over here. So if I pass this point, I actually get less and less utility. So that's one reason why this point of tangency, we can see, is the best bundle that I can get. All right, but I want to sort of focus on this marginal rate of substitution and how it relates to all this stuff. So Here's my budget constraint line. We just talked about how I formulate that. I can write it in 3 different ways here. I can take the number. This is the price per unit A. This is the price per unit B. If I multiply them by all the A's that I have and all the B's that I have, they have to add up to my budget, which I just made W. The alternative is I take my budget and I divide it by the price of B, and I subtract A times the price of A divided by the price of B, or I could write it this way. This is the same thing, W divided by 5 minus, and this is just 2A, and that gives me the function that represents this. So if this curve here has a slope of -2, which corresponds to this slope here. And so this up here, this is my W divided by $5. So this is my attempt at a $sign with a trackpad. I hope it makes sense. All right, so that's my W over 5, that's my y-intercept, and this here is the slope, the -2 slope. Okay, now I'm asking a question here. What is the marginal rate of substitution at the utility maximizing consumption bundle? Well, as by the definition I just gave, this is the utility maximizing consumption bundle. And the marginal rate of substitution is just if I were to draw a tangent line at the bundle, and then I took the slope of that tangent line, then that is the marginal rate of substitution. Well, it just so happens that the slope of the tangent line to the utility maximizing bundle is going to be equal to the slope of the budget constraint line, because by one explanation that I just gave you, the budget constraint line it must be tangent to an indifference curve at the utility maximizing bundle. So we know that the MRS here is going to be the negative of this slope. By definition, MRSs, we always take it's the negative of the budget constraint slope. So this is me trying to write slope. So just conventionally, we take the negative of this, but so that the tangent here, so this is -2. We know that this tangent line is -2. We also know the budget constraint line is a tangent line, so of course, because they're the same line, they have the same slope, so our MRS is equal to 2. So that's where we get the 2 here. So we have to think about, what does this MRS equal to 2 mean? All right, well, so if I remember what my definition of MRS was, is if it was kind of like my delta B over delta A. And so this MRS over 2, or this MRS of 2 means that I am willing, if you give me 1 unit of A, I will give you 2 units of B and be just as happy. So that's how much I'm willing to substitute. I value B such that 2 units of B is worth 1 unit of A. So I don't value B as much as A, but I do value it, and I value it so much that 1 unit of A is worth 2 units of B. That's what an MRS equal to 2 is. 1 unit of the x-axis is worth 2 units of the y-axis. Okay. All right, so now if I look at this, so this is, I'm just writing out on the slide exactly what I've kind of written out here. There's my MRS of equal to 2. The equimarginal principle states that these two things have to be the same, and so we're trying to then figure out what do we mean by the equimarginal principle. And so what do we mean by MRS is equal to 2? Well, MRS equal to 2 that's how many units of B I'm willing to trade for 1 unit of A, but then let's think about the prices here. Look at this, that the price of A is $10 per unit, and the price of B is $5 per unit. That means that the market agrees with me. So at the utility maximizing bundle, the market is willing to give me 2 units of B for 1 unit of A. Just like my own personal preferences are that I would prefer 2 units of B for 1 unit of A. So they equal each other. So that's good. So that's what that means, is that my values are aligned with the market values. Now, the question that we have so you might say, okay, that's fine, but what does that mean? Well, let's consider what would happen if we were actually sitting on a bundle that was up here. Okay, so it's still on my budget constraint line, but if I think about it, the indifference curve that comes through here is going to be steeper, right? So the budget constraint line, I can't help the budget constraint line. The budget constraint line slope is -2. That's just what it is. That's because the price of A is twice the price of B, so the budget constraint line's always got to be -2. But this bundle here, because it would be on an indifference curve, it has a very, very steep indifference curve. So for this bundle right here, my MRS, you remember it's delta B over delta A, it's rise over run. So the delta B over delta A for this indifference curve, so if I were to draw a tangent line to this indifference curve, it would be nearly vertical. So this delta B over delta A would be much bigger than 2. Okay, so up here, I am willing to trade many, many more B than 2. So if you give me 1 unit of A, I will give you 50 units of B. That's what this steep slope means here. So if you give me 1 unit of A, I will jump way up on the indifference curve, so if I take away 1 unit of A, I need to get that many B back. But if you give me 1 unit of A, I'm willing to jump way down in my number of B. So I'm willing to trade lots and lots of B for 1 unit of A. So what this means is that at this point, I like A much more than the market does. So that's what this means. The market likes A to the point where if you give me an A, I'll give you 2 B's. But I, at this point here, because I don't have that many A, so at this level of A and at this level of B, I have so many B that I don't really care much about them, but I have so few A that I really care about these A, and I would like more A. So I value A more than the market does. So what do? I'm going to sell some of my B. If I sell some of my B, then that means that I'm going to move down in the number of B that I own. So this is where I'll be, afterwards. But what I'm going to do with that money that I made from selling the B is I'm going to buy A. So if I buy A, I'm going to increase the amount of A that I have. And so now I sold B and bought A, and now now my bundle is here. And now this bundle, the indifference curve that crosses through this bundle is not as steep as the indifference curve that crossed through this bundle, which means that by shifting my allocation to have more A and less B, I've brought my values more in line with the market values, but I still am willing to trade more A for B than the market is. So I still value A slightly more than the market values A, and so it's still worthwhile for me to sell more B's back to the market and buy more A's. But this process stops when my interests and my values are aligned with the market. So at this point, if I sell B, the best I can do is get the same amount of A. Like there's no indifference. Like yeah, I could sell B and I get money to buy A, but it's not going to increase my utility any. At best, it's going to leave me right on that point, and at worst, now I'm going to actually go down in utility. So because I'll now have kind of more than I need. So that's what I'm trying to get at with this market rate of substitution versus if you calculate the budget constraint, that'll tell you how much if the slope of the budget constraint line is how much the market values one good over another. But the slope of the indifference curve is how much you value one good or the other. If those two slopes are out of whack, so if one is steep and the other one is shallow, then you're living in a world where the market values something differently than you, and you should capitalize on that. And the way you capitalize on that is selling the thing that you care less about and buying the thing that you care more about. And the market naturally will be happy with that because your interests are different, your values are different, then it will end up being better for everybody because you'll be giving the market more of what it wants and it will be giving you more of what you want. But there's a limit to that, and the limit to that is when your interests are finally aligned down here at this bundle here, where now the slope of the indifference curve is equal to the slope of the budget constraint line. That means that you can't do any buying and selling to increase your utility. You can increase your utility here, but you can't do it here. All right, so I'm hoping that gives you a better intuition into this marginal rate of substitution and this equimarginal principle, because I think that's important. And there's a lot of interesting questions that I can ask about those. So with that in mind, go back to Canvas, and those are the last questions I have for this little refresher, and hopefully that is helpful in thinking about how to make these more quantitative problems go.